Good afternoon, students. Can you all hear me? In last lecture, we studied regarding relevance of mathematics and set theory, as well as we have completed mathematical induction too. So from this, we are going to start with unit 4, that is exponents and logarithms. Now, what does an exponent mean? Something raised to power, right? So anything raised to power will be a exponent. See, this is just an introduction over here. Now, exponents are nothing but in our 10th standard or 8th standard, we studied law of indices. Same way, here also it is in terms of exponents. Now, when do I say exponents are there? Something raised to, let's say a raised to n, then your n becomes your exponent part. And we know anything raised to 0, that is here your a shouldn't be equal to 0, then anything raised to 0, the value is always 1. Similarly, when a raised to 1 is there, it becomes a. Now here, your a is what? The base, and n is called as the exponent. When I say a raised to nth power, at that time I'm multiplying a into a up to what? This whole term is up to n, where n is specifically a natural number. If it was a whole number, that means it was 0, so it becomes 1. Now, originally, how do we read a raised to n? A raised to nth power. But when you are having powers over here, that is a square. At that time, we read it as a squared. Here, I read it as a cube. Henceforth, a raised to 4 is there, then quadrant. The See, the exponential a raised to n is also defined when the exponent is negative integers. Now, there are two types of integers, right? Positive integers and negative integers. Positive means what? It starts from 0 and ends up to infinity integers. All of those, here your a shouldn't be equal to 0. Similarly, in this form, understood till here? After this, negative integer exponents. These are ones which starts with minus power. Anything raised to minus power, let's say a raised to minus 1 is there. It is represented in which form? 1 upon a, because this term goes to the down, and when it goes to the denominator part, it becomes a raised to 1. But 1 is there, therefore we don't write over here. Similarly, if I'm having a raised to minus n, at that time it becomes a raised to minus n, and below you will have 1 upon a raised to n, where your a raised to n term is written in this form, because these are n times multiplications. Understood, students? See, here they have given the example. We know 2 square is what? 4. But what if I write 2 raised to minus 2? Then it will be 1 upon C. Through this 2 raised to minus 6 they have taken. So 1 upon 2 raised to 6. You have to multiply it by 6 times. So the value will be 1 upon 64. Now, when your exponents, that is this part, when in terms of negative numbers, If your exponent is even number, then your value will be positive. If your exponent value is odd number, then it will be a negative. Keep this in mind. After this, we see when we talk about computers, we know there is binary number system, that is 0 and 2, correct? Mostly binary system stands for two parts. So in this number system, positive powers of 2 are much of importance. Now, exponentials with base 10 is used to write very large or very small numbers. Now, when we talk about base 10, it consists of logarithm, which we are studying afterwards. Now, see, this is the application for exponential. What is the application they are saying? The first one is to write the speed of light, distance between stars, dimensions of bacteria or viruses. Numbers are written using scientific notation. Now we know speed of light is faster than speed of what? Noise. Now in school we studied law of indices. Here you're having laws of exponents. See, the first case for that is a comma b are real numbers and m and n are integers. Now, the first one is whenever you're having a raised to 0, then the value is 1. And this sign is what? A shouldn't be equals to 0. That is, a is not equal to. This sign is for not equal to. When you're having a raised to m into, this symbol stands for into sign. Huh? So a raised to m into a raised to n, it gives us a raised to m plus n. See, the example here you are having 3 raised to 2 into 3 raised to 4. So how will you do? Either way round, you can do by this method or else by this they have shown. When I'm talking about 3 raised to 2, so I need to multiply 3 twice. And when I'm talking about 3 raised to 4, I need to multiply it by 4 times. So when I solve this part, I'm going to get 3 raised to 6, which is nothing but 3 raised to 2 plus 4. We use this formula. Now the next one is a raised to m into n. So a raised to m into n. See, the difference over here and here is, here the bases are same and both are different. But over here, your base is one type, and in between you're having multiplication. So 3 raised to 2 into 4. So here you need to write this 3 raised to 2 4 times. So this is nothing but 3 raised to 8. That is 2 fours are 8. Now this is like we studied 2 into 3 raised to 4. So what do? Originally they have solved it by our original methods. That is 2 raised to 3 4 times they have written it. But this is nothing but 2 raised to 4 into 3 raised to 4. Earlier we studied when we are having denominator factors. That is the exponent is in the denominator part. At that time, you need to shift it towards numerator. If I'm shifting it towards numerator, it will go up and change the sign. So a raised to m upon a raised to n is nothing but a raised to m minus n. Let's see this example for it. 2 raised to 5 upon 2 raised to 2. Now how will you do it? 2 into 2 into 2. I have taken it 5 times and then divided by 2. So the answer which I am going to get is 2 raised to 3, which is nothing but 2 raised to 5 minus 2. Is the screen visible to you all? Yes or no?
Yes, ma'am.
Are you understanding?
Yeah.
Because these are the basics. Now the seventh rule is a raised to minus n. Again, the same thing. It is in the numerator part. So whenever it goes to the denominator, it will change the sign. Download online from your website of YCMU. Now let's see. Let's take one, two examples. What is the value of a raised to 0 if a is, see, this sign was for not equal to. When a is not equal to 0, that means the value is 1. Now, what is the value of 0 raised to 0? Can anyone tell me? What will it be? See, here a shouldn't be not equal, a shouldn't be equal to 0. At that time, the value was 1. So obviously, 0 raised to 0 will give me 0, na? Or will it be undefined quantity? Try to solve this sum. And I will ask this question in next lecture. See, the options which we need are either 0 or it should be an undefined quantity. Will it be an undefined quantity or will it be a 0 quantity? Now, fractional exponents and surds. See, till now, what we studied was exponents type. Now, surds is a term, I don't think so we had. This must be in your subjects only. Now, surd means what? We are going to discuss it later. Before that, one inverse operation of exponential is nothing but obtaining roots of a number. Now, see, one inverse operation of exponential. Exponential is in which power? Inverse operation of n. So, anything. See, below only they have written it. One inverse operation of exponential is nothing but obtaining roots of a number. Correct? Here you will have what? Roots. Let's see the example. So 2 raised to 5 is equals to 32. Here, how do I read it? 2 is the fifth root of 32. Correct? So this will be my inverse operation, that is 5. Fifth root of 32 is what? 2. Now this one are the laws of fractional exponents. See, earlier only we had this. They have just written it down in terms of fractional exponents. Now let's talk about this note. A number which can be written in the form of p by q, where p and q are integers and q is non-zero. Obviously, it should be a non-zero part. If it was 0, then whole fraction will be a not defined number because it will tend towards infinity. So then only I can say it is a rational number. And numbers which are not rational numbers are called as irrational numbers. Let's see. So root 2. Now root 2 value is what? 1.414, something like that. So obviously this becomes irrational. Similarly, for irrational numbers, the decimal representation is non-terminating and non-recurring. See, I talk about what? Root 2. So they are what? 1.41414. And root 3 is, I guess, 1.73, something like that. Now all integers are what? Rational numbers. Also the numbers, see, half, 4 by 7. Because here the value of q is what? Non-zero. So they are all rational numbers. But see, all of you know odd, even, prime and composite numbers. So here 4 stands for what? Composite numbers, and 2, 3, 5 becomes what? Prime numbers. Why? Because 4, under root of 4 is what? 2. So it becomes a rational number. But what about under root of 3? Obviously, we don't have anything raised means in terms of root 3. So therefore, they becomes a not rational numbers. So they are irrational numbers. Now, what does a surd mean? A surd is a number where this is possible, that is, nth root is possible if and only if the a value should be what? A irrational number. And n shouldn't be equal to 1 because it is a natural number and a is a positive rational number. That means example for this will be, this should be what? N shouldn't be equal to 1 or n should be equal to 1. If I talk about 1 and a is a positive rational number. See, all of these terms are positive rational numbers, correct? And here the term is what? N is what? Equals to 1. Now let's see the examples given below. Now from this, root 3, earlier only, let's take the other one, this one. Cube root of 2. Obviously, you won't be able to find it, so it becomes irrational number. Fifth root of 8. Now see, here the value is 8, but it is what? Raised to the power of 5. So obviously, you know, only 3 times you are going to get 2. 2 into 2 into 2. This is how you write 8. But you need to find fifth root. Therefore, it becomes a surd because it will be a irrational number. Similarly, for fourth root of 20. So all of this are surds. So let's talk about this cube root of 125. Now 125, how do I get it? 5 into 5 into 5. So obviously cube root of 5 will be, 125 will be 5, and it is what? A rational number. So this is not a surd. Now here, see, our surd definition is what? The first one is it should give me an irrational number, and the second one is the part which is there under root should be what? A rational number. But in this example, you can see it is what? 5 is a rational number. We understand. But plus root 3 is not a rational number because root 3 is what? A irrational number. So here your a becomes a irrational number. Therefore, it is not a surd. See, don't get confused over here. Earlier, in our definition, when do I say it is an irrational number? When the value of this root should be a irrational number, and the term which is under the root, it should be a rational number, compulsion. Therefore, it is not a surd. Understood? Yes or no? See, let's take this example. You have to check it. Now see what they have said is over here. Root of root 7. Now the value of root 7 is half, and afterwards again half. So half into half is 1/4, and fourth root of 7, it will always be a irrational number. So it is a surd. Now let's talk about rules of operations with surd. See, nth root of a into multiplied by n. So nth root of a, how do we write it as? It is written in which form? A raised to the power of 1 upon n into what is multiplied? N. And we know a raised to m into n is nothing but a raised to m into n. So n will get cancelled. The value you are going to get is a. Understood? Now after this, nth root of AB. See this example. AB is what? Multiplication of two numbers. So let's see, 20 is there. So you can substitute it in which form? 4 raised to 5. So you can also substitute it. Similarly, here also, nth root of a upon b is written in which form? Nth root of a upon nth root of b. Here, the value of a should be what? It shouldn't be equal to 0, or it can be 0. If it was 0, then what will happen? See, the condition for us is what? The under root value should be what? A rational number. Nah? So if I write 0 over there, will it be a rational number? Below to for p, it shouldn't be equal to 0. And what about a? If a is 0, then it will be 0 into raised to the power of 1 upon n. Correct? Now over here, nth root of a into m. See, a raised to m into n. How do we write it as? A raised to m by n. Don't get confused. Here your nth root you're having. So it will be 1 upon n. Earlier we had a raised to n. So it was m into n. And here it becomes a raised to m by n. Similarly, nth root of now this one. See, any two roots you are having, this root is under this root, then it will be m into n root of a. For example, 2 root 2 and root 3. So what do? Multiply this both. So it will be root 6 of 7. Now order of surd. In the surd, b nth root of a is there. Then b is called coefficient of the surd. See, in our variable form, when you're having 4x, at that time 4 becomes what? My coefficient, and x becomes my variable. Similarly, over here, now b is what? Coefficient for this surd, and index n is called the order of the surd. So this index n will become my order of the surd, and a is called as radicand. So you need to learn these definitions. When do we call as, which one is called as coefficient of surd, which one is called as index of n, and who is called as radicand. When the coefficient of a surd is not written, it is assumed to be 1. See, if I am not having any value over here, So obviously it is considered that it is what? One value. And when the order n of a surd is not mentioned, it is taken as 2. Under root of 2, under root of 4. If you are not having any value next to the root, it is considered to be 2 now, because under root of 4 is what? 2. You have to remember this. Now, see, in the third, 5 cube root of 2. So, if I have to write, don't see over here. We will just discuss it. 5 becomes what? Coefficient of surd. 3 becomes order of surd. And 2 becomes radicand. Now, forms of surd. Pure surd. A surd of the form n nth root of A is called as pure surd, because the value over here for B is what? 1. So it becomes pure surd. Can I say if the value of B is 1, then it is called as a pure surd? I can say that, right? And after this mixed surd, over here B is introduced, and the value of B shouldn't be what? Equal to 1. If the value of B is equal to 1, then it will become a pure surd. Correct? A mixed surd may be expressed, see, they have given the note also. A mixed surd may be expressed as pure surd, as well as pure surd may be expressed as mixed surd. Why? If this is there, then and B is equals to 1, or B shouldn't be equal to 1 over there. If I am expressing B in terms of what? Pure surd, then see, example they have given mixed surd as B equals to 1, correct? Here the value of B is equals to 1. But when we solve this part, you can see you got the B as 4. Similar or like surds. The surds of the form P raised to nth root of A and Q raised to nth root of A are called as similar surds. So when do I say they are similar surds? See, you can see only the value of coefficient changes. Value of coefficient is changing. Here the value of coefficient is 5. Here the value of coefficient is 1. And over here it is 6. Then only I can say they are similar or like surds. Simplest form of a surd. When do I say it is simplest? If the radicand A has no divisor which is in nth power of rational number. Now by this sentence, what do you understand? A shouldn't have any divisors of nth. So obviously it will be a nth power of rational number. And the radicand A is not a fraction. Now here it shouldn't be a fraction, and n is the least such power. For example, see, if you are having cube root of 1250, so 1 to 5 is what? For 5 cube. So obviously the simplest form of this surd will be 5 cube root of 10. Now tell me, what is the order of this surd? Can anyone tell me? Yes, Abhilasha. So order of surd will be 3. Now after this you're having logarithms and laws of logarithm. Till 12th, we had logarithms. There we studied that logarithm is what? It is in terms of log power. When do we consider it as a log power? When you're having a is equals to bn and b shouldn't be equal to 1. If b is not, if b is equals to 1, then log 1 is what? 0. So keep this in mind. So then we represent n equals to log. Now, how do I read this sentence? It is written as log root of b to the base a is what? N. So the logarithm equivalent form is a equals to b raised to n. So it can be represented in which form? N is equals to log ba, log to the base b into a. For example, 7 raised to 0 is equals to 1. How do you represent? N is equals to log, here this was your b, so it becomes b over here into a part. Now here you need to understand it. Log to the base a, 1 equals to 0 for all a not equal to 0. See, if you are having log 2a, the value will be different because a raised to 1 is what? 1. See, this sign is for equal to, I guess, because if you are having equal to sign, then only it will be log 1 and log 1 is 0. Now over here it is saying it is 1 when a is what? Equals to 0. If a is equals to 0, then a raised to 1. So a raised to 1 will be what? Will it be equals to 0 or will it be not equal to 0? Try to think
Not e-
about it.
not equal to.
Here it shouldn't be not equal to 0, right? Because
Yes.
if I'm because here they are mentioning that a raised to 1 is what? A now. So this whole value, not in terms of a, any log 2 raised to 2, sorry, log to the base 2, this will also give me the value of 1. Logarithm log BA are defined only for positive values of A and B, where B shouldn't be equal to 1. Now we know there are two types of log. The first one, this is log when the base is what? 10. It is called as common log. And when the base is e of log a, then it is called as natural log. See, both are there and both the values are giving you a different term. When you're having 10, it is what? 10 raised to 1. So log 10 is what? 1. See, it is simple way to understand. Check over here. 10 is there. 10 is what? 10 raised to 1. So your log 10 value is 1. You don't need logbook for it. Similarly, if you are having 1000, at that time, it is what? 10 raised to cube. So we just need to write this n term. Now 0.1. How do I write in terms of 10th power? Now 0.1, you need to multiply it by 10. As well as if I'm multiplying it by 10, I need to divide it by 10. So the value will be 1 upon 10. And 1 upon 10 means if I have to shift it towards numerator power, it will be negative. So minus 1 and so on. Now for this. the logarithm of a to the base e. Now see students, here you can understand logarithm of a to the base e. That means how do you represent logarithm of a to the base e? Now here they have done a printing mistake. What is the printing mistake? Logarithm of a to the base b. It should be in this form. Understood? Just make it correctly. Because see, b is what my base now. So it should be b base b and logarithm of a, this part. Log of a to the base b. This is how you read it. Now see, these values are there in your logbook also. E equals to e raised to 1. So your log e, see, here also you got the value of 1, correct? And here also, because now originally, if I'm talking about common log, you don't need to write or specify that you are taken base as 10. But when we talk about natural log, you need to mention over there that you have taken your base as e, or else you can either write it as ln. It is a natural log symbol. But according, if we are going by your textbook, you need to write e, log e. Similarly, here also, if you're having e as what? Square, so it will be 2. Now, if it is in power of -2, so again it will be -2. Now, earlier we studied of laws of exponents. Now we are talking about laws of logarithms. If a and b are positive real numbers, x is a positive real number, such that x should be what? See, if your x value is 1, then what should it be? We need x value as either 10 or e. So x shouldn't be equal to 1. N is a real number. Then the following property holds. See, when you are having a combined multiplication of log, if we split it, it will convert it into plus sign. And if you're having combined division of log, then if I split it, it will give me minus sign. Let's see example for this. Log to the base 5, 25 into 125. So I can see, we can't multiply this, right? Because it is a block log. Therefore, we split it into two types. Now 25 can be written in its form 5 raised to 2. So the answer will be, for this will be, we know a raised to a gives me 1, but here the power is 2, so it will give me 2. And 5 raised to cube gives me 3. So the value for this answer is 5. Same way round for log x a minus log x b. Now log x raised to n. Here, when you're having nth power to this side, you can shift it towards the base of log over here. That is the index part. Now log x raised to a. See, this one is similar to this part. We are taking the nth power. Same way, the nth power over here is a. See, they have taken this example. It is the same one. Now x raised to log to the base x raised to a. This is nothing but a. Now how do you solve it? Now see, log 10 is there, right? And here your base is what? 5. Now look over here. If you're having log base 5, so this value should be what? it should tend towards point, and this is nothing but 5. How do you get it as 5 then? It should be 5 or it should be 10. Students, it should be 5, na? A value is 5. Now, what is the meaning of this sentence? See, log x raised to a. Log x raised to a. Where is it? Log x raised to a gives me n. But this n is what? A is equals to b raised to n. So my a value is what? Here my a value is 5 and b value is 10. And originally from this exponential, what do I know? It is represented in which form? A is equals to b raised to n. Now we know a value is 5 and b value is 10 raised to n. So your n value will be, you need to find it in log. Simple. Now anti-logs are those, see, the process of finding anti-log is just the reverse of finding log. Now, how do we find the log? When your formula was a raised to bn, then we shifted it as n is equals to log to the base b into a, correct? Now, in anti-log, what happens? Anti-log of base b, this is same. But instead of a, what are we going to take? Check over here. If the value is n over here, so this becomes my n value equals to, sorry about that. Let me write it properly. See, this is what my n, where is it going? Over here. So anti-log of base is b, that is 10 into n is giving me what? A part. Understood? So from anti-log, I can find a. Now, anti-logarithm is found using the same base as that of a corresponding log. While doing complicated calculations, we need anti-log to find final answers. Now, what is left? Only 2 topics are left. Then we have completed this part. Now, convergence to a different base. Now, here, see, log to the base b into a is there. You need to make it different bases of this both. So you need to add one more base. And now originally, which base do we add? That is the 10. Log to the base 10 or else the even. Correct? See, in changing the base, it should be from e to 10 or vice versa. Vice versa means what? It should start from 10 up to e. So how do I change base of this? You need to include another base. Then only I can divide it. Let's take an example for this. Now log e, log to the base e into 100 you are having. Now you need to include one more term. Now here we have used e. So the other one is to use 10. So log 10. So this becomes my b part, right? So b part is to the denominator part and a part is to the numerator part. Let's take this one. Log 2 into 64 is equals to 6. So here the value for this is 6 and you need to shift it basis. So how do you shift it? You need to include 10, correct? Yes or no? Or in terms of 2. See, the values you're getting are different values. They won't be same because you're shifting your basis. But how do you find it? Now, in your textbooks, they have given this values. Both values are given to us. If you need to change, see, it should start from E and end towards 10. So obviously I can shift this term. Now this one was in terms of log to the base 64. So if I have to find this part, see this one is the B part. See, they have just made a mistake over here. So it should be what? Log, we have taken base as 10. 64 equals to log 10 is to 2. And which is nothing but this part. So obviously, if I want this answer, this will be this upon this, correct? And vice versa. Now, applications of logarithm in complex calculations. So, what are the applications? See, generally the common logarithm that is taken as log to the base 10. We use it because we have logbooks in which we find the answers. Now, how do I solve this term? Now, originally, this is complicated, right? If it was 2 raised to 5, it was easy to us to solve. But now the value is 1.57 raised to the power 5. So what do? Multiply, take log on both sides. This will be a first case, taken log. After that, we know the property log to the base b into a raised to n is what? N into log of a and log of 1.57. Now this one you need to find through your log book. 1.57. So the value is 0.1959. Simple. 0.975. Now, if they have asked to find anti-log also, so what will be the anti-log? Anti-log of this will be, see, this both are there in your logbook only. You need to write it down. Now cube root of 32. So 32 by 1 by 3. Again 1 by 3 is taken. Just find log 32 in your logbook. That's it. Now see 1 by 3 into 1.514. 5051. And anti-log of which one you need to find? Now in your logbook you are having log separate and anti-log separate. So you need to find it. Any doubt in today's lecture? See, today what all did we study? Exponents, laws of exponents. See, here the term is exponent only, but you can also call this as index, law of indices. After that, fractional exponents. After that, surds. Surds are what? The inner part of the root should be rational and the total part of it should be a irrational part. Now, types of surds we studied. After that, log, then laws of log, also anti-log, and how to convert logarithm of a number to a different base, and also to use logarithm in complex calculation. Now for your homework, solve all those self-test series. When you solve it, you will understand they are much easier. Some are much easier. If you're having difficulties in solving the problems, you can ask me in the next lecture.
Ma'am,
Yes?
yeah, I have a problem regarding the set because there is no symbol given in the,
Yeah, right. I have to
yeah,
ask this question. What happened? The first
uh,
mark,
and
it was
and the question number, exercise number 3 maybe, the exercise number 3, 6 and 10th, I didn't understand the questions.
question number 6 and 3. Of what?
Yeah,
Of what?
okay. And then, hello, can you hear me properly?
Yes, yes. Means you're talking
Yes.
about mathematical induction.
No, mathematical induction is easy, but
Okay.
set is also easy, but yeah, which is the which of the following is not true? The intersection union
Okay,
is
about
not
that
given.
only now. Okay, okay.
Yeah, yeah, yeah.
Let me ask the senior once which symbol you have to use over there
This is okay, okay, okay.
because I
That
also
will be
don't.
good. Yeah, I know the answers, but don't know the exact answer because there is no symbol.
Okay, okay. I will
And
discuss
the
it.
Cartesian r into r, that is question is, I don't know.
Cartesian product you're talking
Yeah,
about.
r into r. The no, in the exercise self test. Yeah, 10th.
Okay, R into R. Now see,
Yeah,
R into R is what? Real number cross real number. Correct?
real number. Yes. Hmm.
So real number, R into R will be what? Your number will be 1,
1,
2.
2. Yeah.
Will
Hmm.
it be 1, 2? Real number is whole, no?
Yes.
Your negative will be my real number. So negative numbers will be also included. So this
Yes.
option is not.
A. No, no.
So A is also not possible.
Yes.
You can see minus sign is there and minus sign is there. Understand?
Mm-hmm. Yeah, 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 yeah. Okay, okay.
So probably this will
Understand.
be there, but here the symbols are missing.
Symbols are missing. That's why
Let
I'm
me ask,
confused.
let me ask about it to senior.
Some examples are easy to understand if there is not symbol present, but some are difficult. So we need to know the symbols.
Okay, okay, sure. In next
Okay.
lecture, for sure, I will ask it.
Thank you. Have a good day. So should
Thank
we
you,
leave
everyone.
the